Section 9.6 is about solving rational equations and inequalities. A rational equation is an equation that contains one or more rational expressions. You see an example here. Now, when we had rational expressions without an equation, we had to get common denominators, and then we could add or subtract the fractions by doing that. Well, now when we have equations, we still want to find the least common denominator, but we're going to use that denominator to make the equation a little bit simpler. I'm going to show you how to do that. The common denominator here is 28, because 28 is a factor here, and 4 goes into 28, and then also z plus 2. So that's my common denominator. Now, instead of creating those denominators in all three of these fractions, because I have an equation, I can keep my scales balanced if I multiply the left and the right by the same thing. So what I'm going to do is I'm going to take my common denominator, 28, times z plus 2, and I'm going to multiply it by every term. And it's legal to do that because I multiply the left side by it, but I also multiply the right side, and so I can do that because I have an equation. You can't do this if you don't have an equation. And here's what's nice about it. The 28s will cancel, leaving a 9 times z plus 2. Here the z plus 2's will cancel, leaving 28 times 3, which is 84. And here 4 goes into 28 7 times. 7 times 3 is 21, and then the z plus 2. So what we've done is we've eliminated all of the fractions, which is nice because now we can just deal with this like any other equation by isolating an unknown. So we move the 9z over, we subtract the 42 and then divide by 12, and we get a final answer of z equals 5. Here's another rational equation to solve. You'll want to start by factoring the denominator to make this a little bit easier to see. This is a difference of squares, r plus 1 and r minus 1. So my LCD, my least common denominator, is going to be every factor in the denominator is the maximum number of times it appears. Well, here there's 1r plus 1, and there's 1r minus 1. So that's my LCD. And what do I do with that? I'm going to multiply every term by that common denominator so that I can cancel. So here in the front, we have r plus 1, r minus 1. That's the times the r here. Here, we cancel all that, leaving a plus r squared minus 5. Here we'll cancel the r plus 1's, leaving an r minus 1 times the r squared plus r plus 2. Now working through this, this is really just r squared minus 1. And then if I multiply each of one of those by r, I distribute. I'm going to have r cubed minus r. And then I still have the r squared minus 5 here. On the other side, if I FOIL all this out, I'm going to have the r cubed plus r squared plus 2r minus r squared minus r minus 2. Let's see how that will simplify. I got an r cubed. I got an r squared minus r squared. A 2 minus 1 is a 1r, and then a minus 2. If I subtract r cubed from both sides, they're going to end up canceling, which is good. I want to bring this r over, so I'm going to subtract it from the r that's already here. And I want to bring the 2 over, so I'm going to add it. So now I'm going to rewrite this left side in descending order, r squared minus 2r minus 3. And that's going to equal 0. Now this is something we can solve. This is a trinomial that I can factor easily. Two factors of negative 3 that add to be negative 2 are negative 3 and 1. And if I set those equal to 0, I get two solutions, r equals 3 and r equals negative 1. Now one thing that I did not do on the last slide, because I knew I was going to do it on this slide, is to check these answers. You should always take these answers and look at the original problem and make sure that they don't create a 0 in the denominator. Well, if you look at r equals negative 1 and you go up here to this denominator, if I put a negative 1 in for r and I add it to 1, I get a 0. You can't do that. You can't have zeros in denominator. It would also create a 0 in this denominator. Therefore, we call -1 an extraneous solution. So my solution is just going to be the 3. Here we have a problem that talks about the speed of a current in Puget Sound is 5 miles per hour, so that's the speed of the current. A barge, a boat, travels 26 miles with the current and then returns. So it's going with the current and also against the current, and it takes 10 2/3 hours, and we want to find out what the speed of the barge is. Well, this is a classic distance equals rate times time problem. We have distances, we have rates, speeds, and times, and so we're going to use this formula to figure this out. Now we want to know what the speed of the barge is, so we're going to let r, the rate, be the speed of the barge. And this current is kind of interesting because when it's going with the current, it's going to be r plus 5 is going to be its rate. And then when it's going against the current, it's going to be r minus 5. Now we're told in this problem that it takes 10 2/3 hours. So this number is kind of my total time. So I want to base this problem on the time. If I take d equals rt and I solve for t, I get t equals distance over rate. Since my time is 10 2/3 hours, I want everything to equal 10 2/3 because this is the total time. Which means if I knew the time with the current and the time against the current, and I add those two together, then I'll get the total time. Well, what is the time with the current? Well, I'm going to go up here and say time equals the distance, and then the rate with the current is r plus 5. And then my time against the current is still 26. That's still the same distance, but it's r minus 5. So here we go. The time with the current is 26 over r plus 5, and the time against the current is 26 over r minus 5. And this creates a rational equation that I can solve. Now to solve this, I want to get rid of all the fractions, so the least common denominator is going to be 3 r plus 5, r minus 5. So I'm going to multiply that by all three of them. 26 times 3 is 78, and then r minus 5. Here the r minus 5s will cancel, giving me 78 again. 26 times 3 times r plus 5, which is left. Here I'm going to turn this fraction into 32 thirds, make it improper. Then the 3's will cancel, so I'm left with 32 times r plus 5, r minus 5, which is really r squared plus 25. Now I'm going to distribute everything. So on the left side, the 390's cancel, and leaving me 156r equals 32r squared minus 800. So I'm going to bring the 156 over and then rewrite this in descending. So minus 156r minus 800 and then equals 0. So I'm just rewriting it on the left side. Now each one of these things can be divided by 4. And if I divide the whole thing by 4, that's legal. It makes it a little bit easier. Now I could solve this trying to use the diamond or completing the square, but I just think using the quadratic formula is going to be the easiest way to go. So plugging in and doing all the algebra here, I get 39 plus or minus the square root of 7921. Now that's kind of nice because that's a perfect square. So this is really 39 plus or minus 89 over 16. 39 plus 89 is 128 over 16. And that's going to simplify to be an 8. And then 39 minus 89 is negative 50 over 16, which you can probably plug that into a calculator to get negative 3.125. So those would be my solutions, just verifying that if I take one of those and go back into the original, I will not create a 0 in the denominator. So those are my two answers. Except if you go back to the original problem, we were asked to know how fast the barge was going. Well, since you can't travel a negative speed, the answer must be 8 miles per hour. Now we'll talk about how to solve rational inequalities. That's when you have an inequality with rational expressions. First you find the excluded values, then you solve the related equation, and then you create a number line that divides it up into regions, and you try a point in each region. That's something that we've done back in chapter 6 when we solved for parabolas. So let's look at it in action here. Here's my inequality. First thing we want to find is the excluded values. What values will create a 0 in the denominator? And that would be a equaling 0. So if I put a 0 in the denominator, that's going to be excluded. Second thing I need to do is solve this, and I want to solve it by getting rid of all the fractions. Well, it looks like my common denominator is going to be 8a. So I'll multiply everything by that. Here we'll get a 2. 2 times 1 is 2. Here we'll get a 5. And here we'll get a 4a. Well, except we're going to use the related equation, so we'll use an equal sign. So this is really 7 equals 4a, dividing by 4. So a equals 7/4, or we could even use 1 3/4 if that helps. So my solution is 1 3/4. My excluded value is 0. So I'm going to make a number line. My number line is divided up into these three regions: things that are less than 0, things that are between 0 and 1 3/4, and things that are bigger than that. So we'll try some values, plug them back into the original. I think -1 is going to be the easiest. So when I plug that back into the original, I get -1/4 minus 5/8 is greater than a half. Well, this is all going to be negative. And if I have a bunch of stuff that's negative, I don't care what it is, it's not going to be greater than a half. So this is a no region. Now we'll plug a number in between here. Let's go with 1. So if I plug 1 in, I get 1/4 plus 5/8. Is that greater than a half? Well, this is really 2/8 plus 5/8 is 7/8, and 7/8 is greater than a half, so this is a yes region. And then we'll try a value that's bigger than 1 3/4. Let's go with 2. So 1/8 plus 5/16, is that greater than a half? Well, this is really 2/16, which is 7/16. Well, 7/14 is a half. 7/16 is slightly smaller than that, so that's a no region. So we've tried a value in all three regions. My answer then is between 0 and 1 3/4. We use less thans, and we use the letter A, because that's the letter that's in our original inequality.